The biggest challenge is to get a computer to think like a human. So take a sentence that the Symposium members all struggled with. The play is bitter and funny. Now, it's really easy to get a human being to recognize that bitter and funny in that context are different dimensions, and therefore when you say the play is bitter and funny, that's actually more complex than just saying, for example, the play is bitter. When you add funny, you've added a totally different dimension that makes it more complex. Super easy to get a person to do that. Doesn't take a lot of training at all to get a human being to make that kind of distinction consistently and accurately. However, it's very difficult to get a computer to consistently do that across context. And every solution that you come up with brings its own baggage. So you might think, well, let's do a sentiment analysis. Let's just teach the computer to recognize that bitter is a negative word and funny is a positive word, and anytime those appear in close proximity will increase the score. And as soon as you do that, you see a sentence like the play is not bitter and funny, which actually isn't complex at all. And yet, in that context, your algorithm would have scored it as complex, and you would have misscored it. And every time you add stuff like that, it seems to add baggage that in some context scores well, in some context doesn't. And I'd say that's the biggest challenge that we faced. So I feel very fortunate in this symposium to have gotten to work with some of the most influential researchers in the history of linguistic analysis. This symposium reads like a who's who of complexity research, linguistic systems more generally, both automated and human scored, and includes authors like Peter Sudfeld, Philip Tedlock, includes Peg Herman, Michael Young, among others. So it's a very exciting honor for me to get to work with those esteemed academics. The symposium itself consists of 5 papers, where each of these various authors attacks the challenges inherent in scoring this complicated construct of complexity, the challenges inherent in scoring it on the computer in an automated fashion. So the opening paper is from Peter Sudfeld and Philip Tedlock, where, among other things, they provide a really excellent analysis of the historical nature of this construct, where it came from, how we got here. Very importantly, they discuss why we should care about automating this construct at all, given its difficulties, and they provide some really good arguments as to why we should care about this enterprise to begin with. The second paper is a target article from myself, Lucian Conway, Janelle Gornick, and Shannon Houck. And in that article, we present a new system of automating integrative complexity, which we call Automated Integrative Complexity, rather uncreatively. And in that system is based on a probabilistic and hierarchical model. So it's a little bit different than some of the other things that have been tried. And basically, we spent a couple of years, and you can get the system for free online, by the way. And we spent a couple of years essentially combing through words to see the average likelihood that a particular word or phrase would be scored as complex by a human. So phrases like apart from, which sometimes are complex and sometimes not, and we just did an empirical analysis of when that kind of phrase is going to be complex on average. So it's a probabilistic scoring system. Also hierarchical in the sense that it scores like humans scored. Complexity is scored. Differentiation comes first, and then after that comes integration. So you can read more about it in the target article. The third article is from Philip Tedlock, Sarah Emlyn Metz, Sidney Scott, and Peter Sudfeld as a really good analysis. It's for the first response to our target article. It's a really excellent analysis of what this means, including, among other things, addressing the super important question of what is the gold standard? How do we know we've succeeded at measuring complexity? How should we do that? So they discussed that at length and provide an excellent analysis of that. In that context, they discuss what I think is an important model, that the construct itself is very fuzzy. There's no such thing as a perfect 3. We can't say that for sure. It's not quite like measuring, say, a foot of length. So they discuss the implications of that and what that means, I think, in a very constructive and useful way. The fourth article, also fantastic. I'm really glad and honored to have that article in there, is from Michael Young and Peg Herman. And in that article, they discuss our system some and also introduce a different system, which they'd worked on, that I think, so it's different from ours, but I think it's a complementary system. Some of our system's strengths are that system's weaknesses, and some of its weaknesses are some of its strengths or some of our system's weaknesses. So their system is more based on flexibility. So it incorporates more flexible context cues than ours does. Ours is very specific, based on the probability that a specific word or phrase would be complex across context, and theirs incorporates the context. So there are pros and cons to both of those approaches, and so they discuss some of that, some of the advantages of that particular approach in a very sensible way. And in the final paper, which is from Shannon Houck, myself, and Janelle Gornick, so in that paper, the fifth paper, we sum up points of agreement and disagreement across symposium members. There are things we all agree on, like that humans have to be involved in the gold standard. There are things that we agree on less, so we sum up where we agree and disagree. We compare in that final paper, and we compare and contrast the pros and cons of different types of systems, including specificity versus flexibility. We discuss something that a lot of the symposium members discussed also, that complexity itself is a multifaceted construct, and what does that mean? And so we have some ideas about that in the final paper, and some ways to move forward as we try to automate this difficult to automate construct. Human-scored integrative complexity has contributed to the field in numerous ways. In fact, you can make an argument that it has really shaped the course of the development of the entire field of political psychology, from topics like war and peace, to political ideology, to terrorism, to lying, and the list goes on and on. So integrative complexity as a construct has a long and robust history in the field of political psychology. Automating that construct, on the other hand, has been choppy. Progress on turning this system into something we can score with a computer has been choppy. So, and I think all the members of the symposium would agree with this. And in our various papers, in varying degrees, all of us said something like the following. Yes, we've made progress. Yes, we can confidently say our systems right now are better than they were before. Yes, we can say with some amount of confidence that we're measuring something, at least in the domain of complexity, on our automated systems. Yes, there's some overlap between automated systems and human scoring. So we're moving along. For example, in our system, we get prospective, new data. We're consistently getting correlations between human and our automated system of 0.40. So that's not random. It's clearly measuring something related. That's not a lot of overlap. Okay, so we're a long way from there. But it's not bad, given how hard this construct is to score. So we're moving along, and I think we can all agree, I think all the symposium members would agree, we're moving forward, we've made progress. This goal is not impossible, and we're starting to achieve it. However, we're not there yet, and I think everyone also agrees with that. We've got a long way to go. So the symposium members, we have a lot of disagreements about maybe how best to move forward in certain ways, but I think everybody agrees that it's doable, but we're not there yet. We're making progress, but we're not there. So the symposium lays out some very important considerations in terms of how we're going to move forward together as we automate this difficult to automate construct. How are we going to overcome these challenges, and how are we going to make these systems better? What's that going to look like? So, for example, one of the issues raised by a lot of the symposium members involves the multidimensional nature of the complexity construct itself. So we tend to, ironically, we tend to treat complexity as if it's some sort of unitary construct, but actually complexity is multifaceted. It's hard to capture in one single dimension. So, for example, one of the issues raised by Philip Tetlock et al. In their paper is that we can distinguish what our lab has called elaborative complexity from dialectical complexity. So if you say George Bush was a bad president because he had bad foreign policy, and completely independent of that, he had a really bad domestic policy, that would be a 3 on the integrative complexity scale. You would have differentiated different types of policy on which George Bush was bad. That would be elaborative. You're talking about one side of the issue in a complex way. That's very different psychologically from saying George Bush had a really good foreign policy but really bad domestic policy. That would also get a 3 on the integrative complexity scale, and yet psychologically those are very different. So there was some discussion amongst the symposium members that we need to tease those apart moving forward and have automated systems to tease those apart. And in fact, in our closing paper that Shannon Houck is the lead author on, we present a system, an automated system, an early attempt that does just that with elaborative and dialectical complexity, and present a little bit of data on that. We've had some good early success with that. So that was one issue about moving forward, that we need to think about the multifaceted nature of complexity in the design of our automated systems. A related issue is this. We've got these different systems out there. I mean, in Symposium alone, we've got 2 different automated systems. Which one should we use? How are we going to decide what system to use, and how are we going to integrate the systems, and how should we think about that as a field? It's a very important question. So in our closing paper, we raised a couple points about that. One of the points is that it's not bad to have multiple systems. You know, the principle of triangulation says that it's actually good. We don't want to squelch scientific development by force-feeding only one system, and that there's value in attacking questions with related but conceptually or methodologically independent measurements. So that can be okay. However, we also think that it's possible to get some kind of a super system that maybe hits the sweet spot of that false positive to false negative ratio that takes the best of all the systems that we currently have. We think that's an empirical question. You know, we can empirically run studies to see if there's added value in combining systems, for example. And so that's one of the ways moving forward. All of the Symposium members are colleagues. We all work well together. And so we're excited, all of us, to move forward to figure out what the best systems are, how to use them, and how to integrate them.